Okay, on 7.1, we're going to talk about basically all of Chapter 7. We're going to talk about different types of identities. Now, identities is basically, they're going to be like rules that you can use to simplify trigonometric functions. So let's go over some of them, and then we're going to use them. The first one is the reciprocal identities. And basically, we have cosecant of x excuse me, is 1 over sine x. Secant of x is 1 over cosine of x. And cotangent of x is 1 over tangent of x. Okay. Then we have our quotient. Identities. That says tangent of x is sine over cosine. That's a really important one to remember. And then cotangent, since it's the reciprocal of tangent, it can be cosine over sine. Okay, then we have negatives. So these are things we've already covered, so they should look familiar to them. Negative x inside sine is just the whole thing negative. Cosine with a negative x is just going to be the same thing. It's just cosine of x. And then tangent of a negative x is going to be negative tangent of x. And the last one is the Pythagorean identities. Now the first one, I showed you how we came up with this on the last chapter using the Pythagorean theorem. Okay, so there's the first one. Now if I divide everything by sine squared and use some of my identities that I just used, it's going to give you my next one. Now sine over sine is 1, cosine over sine is cotan, and 1 over sine is cosecant squared. Excuse me, not 1 over cosecant, just cosecant. Okay, so here's one identity. That's the one we talked about last time. And here's another one. Okay? Again, this is supposed to be cosecant, not cosine. Okay? So then if I take it again, and now I do dividing by cosine, sine over cosine is tan, cosine over cosine is 1, and 1 over cosine is secant. Okay, and there's my other identity. Okay, so how can we use these? Well, what we're going to do is we're going to use these different identities to simplify statements. So let's take my first statement. I want to prove that cosine of x times tan of x is equal to sine of x. Okay, so first off, cosine of x times tan of x, if I take tan and use the quotient identity, it says that tan is sine over cosine. And then you see that here the cosines cancel, and all I'm left with is sine of x, which is what we need it to equal. Okay, let's do another example. Let's prove that cotan of x cosine of x plus sine of x is equal to cosecant of x. Okay, so let's change around what we know. We're trying to get it to equal this guy, so I'm going to change everything on the left hand side. First, I'm going to change cotan using the identity, the quotient identity. Cotan is cosine of x over sine of x. Okay? Then here you see I have cosine of x times cosine of x. Hold on. Cosine of x times cosine of x is cosine squared of x over sine of x plus sine of x. Now if I get a common denominator, the common denominator is going to be sine. So that's going to be cosine squared x over sine of x plus sine squared x over sine of x. That's just getting a common denominator. So when we combine those, we have cosine squared of x plus sine squared of x all over sine. And then that on top equals 1, which gives me cosecant of x. And that's what we needed it to equal up there. Okay? Another example. Let's prove that this one's going to be a little bit longer. 1 plus sine of x over cosine plus cosine of x over 1 plus sine is equal to 2 secant x. Okay? So first we basically need to combine these two things together using a common denominator. Now the common denominator is going to be cosine x times 1 plus sine x. Okay, so on the left one, that means multiplying that guy by that, so it's 1 plus sine x squared. And then this one over here is going to be cosine squared x. Okay, when I multiply that out, let's see here, I'm going to have 1 plus 2 sine x plus sine squared x plus cosine squared x and then all over cosine of x times 1 plus sine of x. On the next page, I want to point out that this guy equals 1, so I'm going to take it and combine it over here with this one. So I have 2 plus 2 sine of x all over cosine x plus 1 plus sine of x. I'm going to factor out a 2, leaves me with 1 plus sine of x, cosine of x, oops. 1 plus sine of x. What cancels? The 1 plus sine, and I'm left with 2 over cosine of x, which is 2 times 1 over cosine of x, which is 2 secant x, which that's what we wanted it to equal right here. Okay? These are called verifying identities. They can be tricky, but if you just use all your rules, they'll usually kind of fall into place. Okay. Okay, now, the last one that I'm going to do here is a little bit trickier. We're going to prove that tan of x minus cotan of x over tan of x plus cotan of x is equal to 1 minus 2 cosine squared of x. Okay, so taking the left hand side, first I'm going to change tan and cotan with their quotients. So this is going to be sine of x over cosine of x minus cosine of x over sine of x all over of x, cosine of x, plus cosine of x, sine of x. Okay? I have to get a common denominator. On top, the common denominator is going to be cosine of x, sine of x. So on this side it's going to be sine squared x minus cosine squared x all over sine squared x plus cosine squared x all over cosine of x sine of x. Okay? Now let me point out some things here. These two are going to cancel with each other. I'm left with sine squared x minus cosine squared x over sine squared x plus cosine squared x. Now that on bottom is just 1. So it goes away too. So I have this. Now I can't use that I can't use the identity that says sine squared x plus cosine squared x is equal to 1 because that's a minus sign in there. But what I can do is I can make it look like that. If I subtract sine from both sides, well, if I solve for sine squared x is going to be equal to 1 minus cosine squared x. So if I substitute that into this guy, this part in for this sine, I'm left with 1 minus cosine squared x minus cosine squared x. And then you see from there, what we're left with is 1 minus 2 cosine squared x, which is what we wanted right here. Okay? This is verifying identities. Okay, that's all for this lesson.